Hi, students. Welcome again to our lesson on hydrometer. Let's solve this question and end here. A hydrometer with a uniform cross section is 6.0 cm long and has radius 2.3 centimeters, flows in two different liquids, namely kerosene and water. It was noted that 2.6 of the hydrometer was above the kerosene surface and 1.9 of the same hydrometer was submerged in water. If the mass of the hydrometer and its content is 10.85 kilograms, calculate the I, weight of the kerosene displaced, II, volume of the submerged part of the hydrometer in water, III, relative density of the kerosene, and we are asked to take G as 10 meters per second squared. So pause the video and try and see if you can write the question so that you follow the solution. All right, now let's look at our solution. What information are we given? We are given the length of the hydrometer as 6 centimeters. We are given the radius of the hydrometer as 2.3 centimeters. We are given also, and according to the question, we have been told that the hydrometer is floating in two different liquids, right? Okay, so let's see, this is our containers. And then let's see, this is the water, the kerosene one is also water. And according to the question, it's saying that so let's call the first one kerosene if you follow the question. The question talked about kerosene before water, okay? Say 2.6 is above the kerosene surface. And let's call this water. So if 2.6 is above, the whole length is 6 centimeters. And 2.6 is above, meaning less than half is above. So it means a lot of it is immersed. Great portion is immersed. Though it's not drawn to scale, but my drawing has to be a bit reasonable, okay? So this is 2.6. Sorry, 2.3. I'm sorry. 2.3. Okay. So what do we mean by this? If 2.3 is above, then from the whole length is 6. So what will be this? We can bring it here. What will be the length of this? It's going to be 6 minus 2.3 and we will get 3.4. Okay, so this information will help us get the length of the submerged part in kerosene. Then it says that it was also known that 1.9 is submerged in water. So 9.9 means small portion is submerged in water. So greater portion is above, all right? So I'll get, I can do drawings, I'm drawing like this. So that I can call here becomes my 1.9 according to the question. Then this one will help me, this should help me get the part above. The part above is going to be 6 minus 1.9, I'll get 4.1 centimeters. So this is what I need to get note of. Then the question also gave us the mass of the hydrometer. We are giving mass of the hydrometer as 10.85 kilograms. Right. So what do we want? We are told, the first part of the question, we are told to find the weight of the displaced kerosene. And straightforward, you need not to worry. It is floating. Definitely, the hydrometer is floating in the kerosene. So how do I get the weight of the displaced kerosene? It's the same as the weight of the hydrometer. So if I find the weight of the hydrometer, okay, so I will say that weight of the hydrometer, because we are given the mass of the hydrometer, is equal to weight of what? Displaced kerosene. And we were not given mass of the displaced kerosene, but we were given the mass of the hydrometer. So if I get the mass, if I get the weight of the hydrometer, that will be the same as the weight of the displaced kerosene. So we are answering the I. So this is mass of the hydrometer times G. And this gives us what? 10.85 according to the question times 10. And this gives us 108.5 newtons. Therefore, weight of displaced kerosene is what? 10.85 newtons. Sorry, 108.5 newtons. Great. So let's look at the second part. In the second part, we are told to find the volume of the submerged part of the hydrometer in water. Volume of the submerged part of the hydrometer in water. So they are referring to this part. This part is what they are referring to. Volume. Luckily for us, we've known the length of the submerged part in water. It was given as 1.9. So meaning if I get is there any way we can get the cross-sectional area? We can get the cross-sectional area because the hydrometer, looking at the hydrometer, because it has a uniform cross-section, the shape is cylindrical. Okay, yeah. So if I get the cross-sectional area, get the cross-sectional area, we were given the radius, and I multiply the cross-sectional area by the length of the submerged part, I'll get the volume of the submerged part. Okay, so this is what I'm trying to say. I volume of the submerged part is equal to cross-sectional area of the hydrometer. Some calculations, I just make it A times the length of the submerged part in water. Okay, we are looking for length of submerged part in water according to the question. So look at it. So it's going to be the cross-sectional area of the hydrometer times the length of the submerged part. The area wasn't given directly, but we were given the radius. And looking at the nature of the hydrometer, it's cylindrical, right? So what do? The area, because we were given the radius, is pi r squared times LW, right? So what do we get? Pi, our radius was given as what? 2.3 squared times length of the submerged part in water according to this is 1.9. So I multiply by 1.9. And when we calculate, pi is constant, so our calculator gives us this answer directly. 576 volume. It is going to be in cm cube. So that will be the second part of the question. Good. Now let's look at the third part. We are looking for the relative density. The question wants us to find the relative density of the kerosene. So how do we find it? Do we know the density of kerosene? We were not given the densities, but we were given, look at the diagram, we were given the length of the submerged parts. So it becomes simple for me to use that formula. So I will say RD for relative density of kerosene is going to be the length of the submerged part in water times the length of the submerged part in kerosene. Okay, so what is it? The length of the submerged part in water is a 1.9. That of the kerosene is a 3.4. 1.9 centimeters, 3.4 centimeters, and this gives us what? 0.559 unitless. Right, so this answers our question on what we were given. You can replay again and follow it. Now I want you to try this using the equations we have discussed so far. Try and see if you can solve this question. And if you solve it, you get 9.47 centimeters. Hope to see you again. Stay connected to our channel. Subscribe, because in the next lesson, I'm going to treat another topic with you. And I hope you are going to enjoy more physics and other wonderful subjects on this channel. Thank you so much. See you next time.